Bismillahirrahmanirrahim. Yalla bina. So, today we're going to explore a fascinating concept called related rates. Have you ever wondered how two or more changing quantities are connected in real time? Like how fast a balanced volume grows as you inflate it, or how quickly the shadow of an object changes as the sun moves across the sky. So, rates helps us to solve these kinds of problems. Okay, so we have here a police car approaching a right-angled intersection. From the north is chasing a speeding car, okay, that has turned the corner and is now moving straight east. Okay, so this car moved like that. Okay, so here's moved like that and then moved like that. Set up a relationship, then find an equation that shows the related rates of the vehicles with respect to time. Okay, so first of all, there is something that is called implicit differentiation. Okay, implicit differentiation is about what? Let's say that we have, let's say that this is C, the hypotenuse is C, this leg is A, this leg is B. So if you put a relationship, so it will be Pythagorean theorem. So it will be C squared equal A squared plus B squared. Okay. So with respect to time, so our derivative will be with respect to time, which is T. So I will do the differentiation with respect to T. Okay, so C squared, if we do an implicit differentiation, it will be 2C dC over dt. And A squared, 2A dA over dt. B squared, 2B times dB over dt. So this is the implicit differentiation. Okay, that's it. So this is how we solve a question like that. Okay. So what is C? C is the length of the hypotenuse. A is the length of this leg. B is the length of this leg. dC over dt, it refers to the rate of a change of the length of the hypotenuse according to time. And also for A, the dA over dt, it refers to the rate of a change of the dimension of A with respect to time, and B as well. Okay, so do all variables have a rate of a change? No, sometimes they are constant, like this question. An airplane point A is flying on a horizontal path that will take it directly over an observer O. So here is observer, and here is the plane, okay? The airplane maintains a constant altitude, okay, from the ground, okay? So relate the rate of change of the distance between the observer and the airplane. Okay, so the airplane is flying in a horizontal path like that. Okay, and here is the altitude that separates the observer from the airplane. And here is the distance between the observer and the plane. So the distance, we will call it Z. The constant altitude, we will call it Y. That will never change, okay, because it said that it will maintain a constant altitude. And here is the path, we will call it X, and it will change, okay, according to the motion of the plane. Okay, so we will use, of course, Pythagorean again. So Z squared equal X squared plus Y squared. Z squared will, of course, it will change according to X. So its derivative will be 2Z. This is an implicit differentiation according to time. And X squared will be 2X dx over dt plus Y squared will be 2Y dy over dt. Okay, dy over dt here will be 0 because it said that we will have a constant altitude that will never change. So there is no rate of a change for y. Okay, so let's go through some numbered questions. Okay, first we have y squared equal 3x squared plus 6x, and we need to find dy dt Okay, so this is an implicit differentiation. When x equal 1 and dx over dt equal 2. Okay, y squared, so it will be 2y dy over dt. 3x power 4, it will be 12x power 3 dx over dt plus 6x, so it will be 6 times dx over dt. And then we will substitute 2y dy over dt equal 12. X will be 1 power 3. Dx over dt will be 2 plus 6 dx over dt. So 6 times 2. But here we have a problem. We don't know y or either dy dt. So how can we solve that? I will take the advantage of x equal 1 and I will substitute it here to find y. So y squared will be 3 times 1 power 4, 3 plus 6 is 9. So y squared equal to 9. Okay, so that means after square root, both sides, so y will be positive or negative 3. Okay, so we will try 2 times y, which will be 3. And then after that, we can find dy dt. Okay, next. Okay, we have a rectangle here. Its width is increasing at a rate of 2 centimeters. Okay, so width of the rectangle, we will consider it W. And its rate of change, we will consider it dw over dt. Okay, which is equal to 2. And its length is increasing, so we have L. Okay, and it's increasing at a rate of 3 centimeters per second, so we have dl over dt equal to 3. At what rate? The area of the rectangle is increasing when the width is 4 centimeters. So that means W is equal to 4 and the length is 5. Okay, so now we need to find a relation between the length and the width that will be the area itself. Okay, so we know that the area is equal, of the rectangle is equal to length times width. Okay, now time for to find first the area. So the length is 4. There is no name. Okay, we have just, it is just A. So when we differentiate it, it will be dA over dt. And L, we have here a product rule. So it will be dL over dt times W plus L times dW over dt. Okay, so we need to find the rate, the area is increasing. Okay, so dL over dt is 3 times W, which is 4, plus L, which is 5, times dW over dt, which is 2. That's it. So this is how we find the rate of a change of the area according to the rate of changes, the rates of change for the length and the width. Okay, another question. A spherical balloon is expanding at a rate of 60 pi inches cube per second. Okay, so this is about the volume. The rate of change of the volume will be dV over dt equals 60 pi. How fast is the surface area of the balloon expanding when the radius of the balloon is 4 inches? So R equal to 4. Okay, so he's asking about how fast the surface area of the balloon is expanding. So he's asking about the dA over dt. Okay, so that's perfect. Okay, if we tried to write the area rule of the sphere, it will be A equal 4 pi R square. Okay, let's apply the differentiation. So dA over dt equal 2 times 4, 4 is 8, 8 pi R dr over dt. Okay, I have R, which is 4, but I don't have dr over dt. Okay, let's see that rule. The volume is 4 over 3 pi R cube. Okay, so if we try to apply the implicit differentiation here, so dV over dt will be 3 times 4 over 3 will be 4 pi R squared dr over dt. And we already have dV over dt, which is 60 pi. And R will be 4. Okay, so and 4 pi r square. We have already r, which is 4 square dr over dt. So here we can find dr over dt and apply it here to find dA over dt. So pi with pi, 4 square 16, 16 times 4. So it will be, okay, so dr over dt will be equal to 15 over 16. That's it. Okay, so now 8 pi r, which is 4, dr over dt, which is 15 over 16. That's it. This is how you find the dA over dt. So it will be at the end 30 pi inches square per second.